everyone, hope you're doing well today. What we'd like to talk about in this final section about graphs, or about functions, is dealing with graphs of functions. So I want to discuss how to find something called the domain, how to find the range, which we've defined already, but not with a graph, and how do you know if a graph actually represents a function. So here we go. What is the domain? Now, if you know from your former definition of domain, domain is the x values, okay? It's also called the input, because the input doesn't always have to be called x's, but everything that you have done so far dealing with a function does deal with x's and y's, whereas the range is the y values. And we can often think about y values or range as the output of a function. And so then third I asked, does the set of points represent a function? Well, first maybe the best plan would be to label all of these points. And so the one on the far left, I'm going to label that as -5. And then my y value would be -1. So make sure you pay attention to the scale whenever you're given a new graph. But this scale, every line represents 1. So 1, 2, 3, 4. You see 1, 2, 3, 4. So we're good. So that's -5, -1. This one, the highest point here, the x is 2 and the y is 3. So that's the point 2, 3. And then these two twin guys right here, I'm going to do the one on the left first. That's at 3, 1. And then the one on the right's at 4, 1. So if I list the set of ordered pairs, which it did not ask for, I'm just listing the set, we would have -5, -1, 2, 3, 3, 1, and 4, 1 is the one on the far right. So there's 1, 2, 3, 4, all 4 points. So if I list the domain, remember the domain are the x values. And your homework likes these x values in ascending order, so smallest to largest. So that would be -5 is definitely the smallest one. The next smallest one is 2, then 3, then 4. Whereas the range, we're looking at y values. The smallest y value on the list is -1. And then 1 is twice. Notice we've got 1 2 different times. You only need to list it once when you're dealing with the range. So that point is listed twice because it's 2 separate points, but the y value is the same both times. So -1, 1, and then the highest y value is 3. Okay, so this answered one of our questions, and then the range answered the other question. Finally, it says, does the set of points represent the function? Now remember, a function says for each x, or each input, or each value in the domain, there's only one y. Okay, and we can go back and look at our list of ordered pairs, or you can look at the graph. For -5, there's only one y value, it's -1. For 2, I don't see 2 anywhere else on my x list. 2, there's only one y value, it's 3. 3, I don't see anywhere else, again, on my x list. Okay, 3 only shows up once on my x list, so the only answer is 1. And 4 only shows up one time on my x list, so the only answer just happens to be 1 as well. So for each x, there is definitely only one y, so yes, for the third question, this is a function. So here we go with another example. What is the domain? What is the range? And does the set of points or of ordered pairs, either way, represent a function? So first of all, let's just list our set of ordered pairs. So I have, we can list those in any order you want. Farthest to the left, it looks like we've got 2 different ones. This point right here, lowest left, is the point 1, 2, and then just above it is 1, what is that, 5? Okay, and at the very top we have 2, 6, and to the far right we have 4, 1. So make sure you see those. Now if I start creating my list, again in no particular order, I've got 1, 2, 1, 5, 2, 6, and 4, 1. Again, those are in no particular order. Now the domain, ask for the domain, that's the set of x values. So 1, well, we don't need to list 1 twice, so 1, 2, 4. And the range is in order. See, 1 is the smallest, and then 2, and then 5, and then 6. Okay? Now the real question, does the set of points represent a function? Now remember, for each x, there should only be one y. And you might have noticed that for x equals 1, you get 2 different y values. Right here, x equals 1, I get 2, and x equals 1, I get 5. And we talked about if any of the domain values repeat and you get 2 different y values, then it is not a function. So for each x, there's not one y. And look, the issue happens right here. See how these line up on top of each other? That's a problem. Anytime points line up vertically on top of each other, then it's not a function. And what that's called is the vertical line test. If you can draw any vertical line and it intersects your graph or your points more than one time, then it's not a function. So this graph does what we call, it fails the vertical line test, because I was able to draw, I'm going to erase this mess for you so you can see it a little better, but I was able to draw a vertical line and intersect the graph more than one time. And if you could do that, it's not a function. So that's going to be an important tool for us the rest of this section. And here we go, formally in green, the vertical line test. It says if any vertical line intersects a graph more than once, that doesn't need to be a capital M, more than once, the graph does not represent a function. Okay? Now, so you come over here to the right and we just start drawing vertical lines, just randomly drawing vertical lines anywhere. Well, that only intersected the graph once, right? If I draw a vertical line here, that only intersects the graph once. Only intersects the graph once. You can pick some random area like here. That doesn't even intersect the graph at all. That only intersects once, intersects once, intersects once. In other words, there aren't any 2 points stacked vertically on top of each other, right? So this is a function. So yes, this is a function. And if I ask you why, you could say because it passes the vertical line test. I'm going to put VLT for vertical line test because it gets old writing it every time. Another way to say this is for each x, there's only one y. You love how my letters are jumping? It's because I moved the screen accidentally. If I wanted to do it, I probably couldn't figure out how to do it. Alright, let's try this again. Does the set of points represent a function? In other words, does it pass the vertical line test? So that's really what you're asking yourself. Does this pass the vertical line test? And passing means it doesn't intersect the graph more than once. And look, I find a big old problem right here, right? The vertical line at x equals 4 intersects the graph more than once. So no, it fails the vertical line test, which means it's not a function. So anytime points stack on top of each other right here, just like that, they have to be completely vertical of each other, it is not a function. Now, check out, we got a new graph. Does the graph represent a function? I'm asking you the same questions, but this time, instead of just these random points, you have an entire graph. So all of these values on this, say, semicircle is what it looks like, all are points on the graph. Now, I ask you several things. Does it represent a function? So, does it pass the vertical line test? So if I draw a random vertical line, I'm having trouble drawing a vertical line. Look, it only intersects once here. It only intersects once here. Can you imagine drawing a vertical line that would intersect this graph more than once? And you can't. There are no points on this red graph that stack up on top of each other. So yes, this is a function. If I ask you why, you would say because it passes the vertical line test. Okay, so it is definitely a function. Now we need to address the domain. Okay, now before the domain, remember we did just a list of numbers, but you can't do that for this, right? I'm going to get rid of all my vertical lines. You can't list, this is an infinite amount of points right here. It's every number between some value and some value. So this time when you write the domain, it's going to be in what we call interval notation, because there is no way that you can write down every single value that comes between two different values. And remember, domain are x values. All right, and you're always listing smallest to largest. So what's the smallest x value listed? Well, maybe let's take a look at this. So it goes from, say, this x value right here all the way to this x value right here, right? Now remember, I said x values. So what is that x value? Well, we could label that point instead of just circling it. Let's label this point right here. And that point is -6, -1, right? And this point over here, again, instead of circling it, let's actually label that point. And that point is +6, -1. So this graph goes everywhere. If I put a little line on the x, it goes from this x value all the way to this x value. Not on the axis, I mean, it starts at -6. Okay, so it goes from -6 all the way to +6. The negative ones don't matter because they're y values. Okay, now, do I include the -6? So we got to decide whether we're using parentheses or brackets. Okay, so at this point right here, this -6 is included, so I use a bracket. And this 6 over here is included, so I use a bracket. And this is what is called interval notation. We're talking about every number between -6 and +6. So we say bracket -6 to bracket +6. That includes every number in between. Now for range, we're going to do the same thing, but we're going to consider y values instead of x values. And when you consider y values, you're talking about low to high instead of left to right. So back in blue, we said left to right. Okay, and we did bracket because it was included. For the range, we're going to do low to high, because y values are low to high, right? And then if they're included, we'll include brackets. If they're not, we'll do parentheses. So let's don't do the blue anymore. Let's get rid of all that. Now, how low, get rid of that blue too, does this graph go? Okay, well, this looks like the lowest point, and over here, that point is just as low. So it goes that low, and then what's the highest point? It looks like it's right here, right? So if I put that on my axis, the lowest it goes is here, all the way up to here. Do you agree? Okay, so the lowest is -1, and the highest up there is 5. That's how, and again, I wrote over the top of it, but there it is right there at 5. So it goes all the way to here at 5. Now, do we include those points? Well, yes. At the here and here, those points are included, so I need a bracket instead of parentheses, and it goes all the way up to 5, and that's interval notation. Okay, we go back and get rid of all my scribble on the graph. Now I've got another question for you. F of 0. Now remember, f of 0 means x is equal to 0, and they're asking you what is the y value. So when x is equal to 0, what is the y value? So here's x equals 0. I go meet the graph, and it's that point right there, and the y value is 5. So another way to say that is f of 0 equals 5. Okay? In red, I'm going to do the second one, f of -6. So what is f of -6? Now what that's really saying is when x is -6, what is y? So first go over to x is -6, that's right here, and I go meet the graph, and that's that point right there, and that y value is -1. So I could say f of -6 is equal to -1. Now, we're going to practice that a lot. A lot of people have trouble with domain and range and interval notation and writing these function values. So we're going to practice this with several more graphs until you get the hang of it. All right, next question. Does this graph represent a function? Now, I kept up there in green for you to remind you the vertical line test, which says if any vertical line intersects your graph, which happens to be in red, more than once, the graph does not represent a function. And look, there's a vertical line already drawn over there for you, the y-axis, but I could draw my own. Look, right here. It intersects the graph more than once, definitely. So what does that mean? It means one thing. It fails the vertical line test, which implies this is not a function. Now, definition-wise, what's really happening is for each x, or for an x, there's more than one y. And for example, for x is equal to 1, look, there's a y value here, a y value here, and a y value right here. For x equals 0, there's a y value here, here, and here, which means it's not a function. Now, it's still a relation, it's still a graph, it's still very mathematical. There's an equation that gives you this line, but it doesn't have the special property of being a function. And a function is very important in mathematics, which again, you won't discuss all the properties of functions in this class because we're just running out of time, but you will when you take your next math course. Why or why not? I already answered that, because it fails the vertical line test, right? For each x or for a particular x, example, for x equals 0, there's more than one y. There's a y equals, I don't know, was that 1.8? There's a y equals 0, and there's another y down here at, say, negative 1.8. And that just can't happen. But fails vertical line test is fine to answer that. Okay, question G. Notice I've got a lot going on this page. We know about the vertical line test, so I shrunk it up a little bit. If any vertical line intersects a graph more than once, it is not a function. Let's go ahead and address that. Does this pass the vertical line test? Like if I draw a vertical line here, am I okay? Well, I missed it all together, didn't I? If I draw it here, it only intersects once. If I draw one here, it only intersects once. If I draw one here, it only intersects once. If I draw one out here, it doesn't intersect it at all, which is fine. What happens is if it intersects more than once, it's not a function. But there's no way you could draw a vertical line on top of this graph and intersect it more than one time. So yes, this is a function. If I said y, you could say for each x, there's only one y. Or you could say it passes the vertical line test. Either way, it is definitely a function, okay? Now, what is the domain? Now, here's where the big blue, and you may want to take a picture of this in blue. Domain are the x values, always the x values. You write it down from left to right, and it's typically written as an interval or interval notation, and we've talked about that. So, let's look at the interval for our domain. So how far to the left and how far to the right does it go? If I draw that on my picture, like you're going from this point to this point, right? Left to right. So on my x-axis, it's going from here all the way to here, and it stops. And you'll see that in your homework, they draw a line for you right on top of the axis. Not something you'll see in your next math class, but they're helping you out a lot. So the domain is from the left to the right. Well, what are those values? Well, notice the scale. The scale for every single gray line there is 1. 1, 2, 3, 4, 5. If I go backwards, -1, -2, -3, -4, -5. So what is that value? It's -3. So we're going from -3 all the way to +3. Now, the next thing in interval notation is I've got to decide, do I use parentheses, which means the value's not included, or do I use a bracket, which means the value is included? Well, this point is filled in. So over here at -3, that's included. So I need a bracket all the way. The +3 is included as well. There we go. So that's our domain from -3 to 3. Now range, well, range, right up here it says range is y values. Okay, so that's important. And it's low to high. Instead of left to right, we go low to high, and it's typically written as an interval if you're talking about every number between some number and another number. Now, what's the lowest value on this graph? It's right here. What's the highest value on this graph? It's right here. And if I write that right on top of my y-axis, That's my range right there. Well, how low is it? Well, the lowest value is 1. The highest value is up there at 4. And we use, again, brackets because that point is included, and up here at 4. So that's here and here at 4. Those points are included. And then at the bottom, I've got function notation we have to deal with. Remember, on the first question, f of negative 3, what f of negative 3 means is when x is negative 3, what is y? That's really what that's asking. So first of all, I go over to x is negative 3. I go meet the graph to get the y value, and you see that's 4. So when x is negative 3, y is 4. So the answer to that, f of negative 3, is 4. Now let's take a look at the second question. What is f of 0? Now what that really means is when x is 0, what is y? So I go to the point when x is 0, that's right here. I go meet the graph. Well, what is that y value right there in black? When x is 0, y is 1. So we could say f of 0 is equal to 1. All right, so here we go again. We've got a brand new graph over to your right. Notice there's a little arrow at the end. Now, here's a point I want to make for you. Anytime you see an arrow at the end, that really means that graph is continuing on forever. I could emphasize this by putting kind of red on top of that. That is going that way forever. But now, sometimes, like the software that I use to create the graphs that you're looking at, it doesn't put arrows at the end. I had to make this fancy arrow myself, which was much easier just to write on top of it. But see how the graph, let me erase and I'll put the arrow back. See how the graph, see that little arrow there? He wasn't there. I made him. But see how the graph just kind of ends at the edge? That really implies that that graph goes on forever. So if you ever see that, if it goes right to the edge of your graph, just assume that it goes on forever, okay? So this one does. This goes on to the right and up a little bit too, forever. Now, the first question that is asked is, does this graph represent a function? Remember what that means is, does it pass the vertical line test? Notice I moved the green vertical line test off your notes here, because we know it by now, right? If I draw any vertical line on top of this graph, it can only intersect it 1 or less times. So 1 or 0 times. And any vertical line, look, is only going to intersect just once. There's no way I could draw a vertical line and it's going to intersect it twice. So yes, this does represent a function. Why? Because it passes the vertical line test. So we're good there. This is definitely a function. Now let's get rid of all that test. Okay. Next, what is the domain? Now remember, domain, I still have that above for you, is x values, and you always write it from left to right. So kind of scan, come over to the far left of the graph, over here in the 10 area, there's nothing graphed. And I move along, and all of a sudden, right here, okay, I've got this highlighted in blue now, a point. That's where the graph begins. That's the farthest to the left. And how far to the right does it go? I'm drawing on top of my axis. It goes to the right forever, right? It just keeps going off to the right. So how do I write that in interval notation? Well, first it's left to right, smallest number to largest number. The smallest number that I've got shaded in blue right there is negative 3. Is that negative 3? Yes, that's negative 3. So I'm going from negative 3. How far to the right does it go? It goes all the way to infinity. It doesn't stop, right? So that's positive infinity, way out there to the right. Now, the negative 3 has a bracket because that point is included. I made a big deal about including it there. But now, infinity symbol, it always has a parenthesis around it, always, okay? And since it has a parenthesis around it, because you never actually get there, you just keep going and going and going, that's what you'll always do. So anytime you see an infinity symbol in an interval notation, always use a parenthesis. And there's your domain. All right? Now, range, we're going to try to do the same thing. We're talking low to high this time. Now, I'm going to get rid of my blue line here so I can talk about range, and I'm going to make range green, okay? So what's the lowest y value do you see on this graph? Well, here's the lowest point on this graph, and that's right here at 0. Now, how high does it go? It's tricky. At first, you thought, well, it goes up to about right here, right? Or maybe it goes a little higher. right? Well, how high does it go? Well, you know what? This arrow goes to the right, and it keeps going up forever. Now, it might take a long time to get up there to positive infinity, but it's still going up. This line is not flat, okay? It's not horizontal. It's going up to infinity. So here we go. The lowest is 0. I put a bracket around the 0, again, because this point is included. The highest is infinity, and infinity always has a parenthesis around it. Now, the last question, they want us to evaluate f of 0, okay? So let me get rid of, again, all my scribbling on here, and I want to evaluate f of 0. So what that really means, remember, is f of 0 means if x is equal to 0, that's always your x value, what is y equal to? Well, x is equal to 0 is right here. I go meet my graph. There we are right there. Now, y'all, I'm going to have to just guesstimate, right? That it's not at 2. 2 would be up here a little higher. It looks like it's almost 2. You agree it's bigger than 1.5? My best guess is I'm going to say that's, about 1.8. And sometimes you just have to guess. That's not exact, but I don't have the function value to know exactly what it is, so I'm just going to have to go with my guess, which is 1.8. And listen, I have seen that in the homework, where they give you some where you have to guess as closely as you can. I know that's not comforting, but do the best you can. Just make sure you see that point and then do your best approximation, and that's usually good enough, okay? All right, this might be something you want to try on your own. Pause it for a minute and see how you can do. Now, does this graph represent a function? Does it pass the vertical line test? And if you'll notice, it does. Look. If I draw any vertical line, it doesn't have to be, it could be any random vertical line. Notice it only intersects the graph one time. Any random, I'm looking at one vertical line at a time. It only intersects the graph once. There are no points stacked. Like something like this point stacked on top of this point, that is not a function, okay? But something like this passes the vertical line test. So yes, if you asked why, you could say passes the vertical line test. You could also say, for each x, there's only one y. Now, what's the domain? Now, domain right there at the top for you, that's the x values. The x values from left to right. The furthest to the left, the graph goes as there. The farthest to the right, the graph goes as there. But we're only talking about x values. So it starts here, and if I draw that on the x-axis, it ends here. Do you see that? So I'm just going from the graph to the line, from the graph to the line. There is my domain. Now, what are those values? Well, you notice each gray line is 1. So that's 1, 2, 3, 4, 5, -1, -2, -3, -4. There we go. So this goes from -2 all the way to 3. You see that? So from -2 to 3, at -2, that point was filled in. By the way, how would you know if it's not filled in? It would be a deliberate open circle like that. And I haven't noticed any that show up in the homework like that, but it could happen. I didn't put any in the notes. Now, a lot of you might be thinking, why didn't it stop here? But we're not looking at just on the axis. I mean, this is the farthest right it goes. If I go all the way down to the graph, that's right here, right? So it goes from -2 to 3, and that 3 is also included because there's not an open circle up there at the graph. Now, let's try the range, okay? The range we'll do in green. And we're talking the lowest y value on the graph looks like right down here. It doesn't go any lower than that. And if I draw that on top of my y-axis, how high does it go? Well, it stops right here, okay? And again, that point is filled in, so I'm going this way and this way. So how low is it? Looks like it's at -4. How high does it go? Up there to 5. And those points are included, so I use brackets. Now, next question, evaluate f of 0. Remind yourself of what that means, right? The 0 is the x value. So when x equals 0, it's asking us, what is y? So let's get rid of my green over here. When x is equal to 0, here's x equals 0 right here. I have to go meet the graph, and that's that point right there. What is that y value? That y value is -4. So f of 0 equals -4. Now look, bottom question, that's a completely different guy. We haven't run into that. I'm going to pull out my purple for that. Find x if f of x is 5. So this time we don't know what x is, but what's y? 5. Okay, so y is 5. Then you go out and meet the graph. That's that point right there. That point is what, comma, 5? Well, it's 3, right? So the x value is 3 when y is 5. So the answer to this is x is equal to 3. Okay, so brand new graph, brand new question. So check it out. Look at the lines. You see how they go up and they look like they go up, they almost fall off the graph? That means those arrows go up forever. And see these teeny little cute arrows I put on the end there? It's the best I could do. I can't just draw on top of it. That probably would have been a smarter plan, but I was trying to do it, you know, with the technology that I had without drawing. So assume those go up forever. Don't always assume a graph is going to have the arrows on the end, even when they mean them to be there. But now if you see the graph stop kind of just in the middle, like look, the last problem, see how this thing just stopped right in the middle? That does imply that it stops. It doesn't go on forever. But if you see arrows, it definitely goes on forever. But if you don't, and it looks like the graph goes up to the end there, it probably implies that it does. But this definitely goes up forever. Okay, does this pass the vertical line test? So if I draw random vertical lines, here I'm going to pick one right here. It only intersects once. Even if I pick one right here, I can't draw a vertical line anymore. It only intersects once. So this passes the vertical line test. So yes, this represents a function, again, because any random vertical line that you draw on top of the graph. Another way to picture this is a noodle. See this black line right here, at the vertical black line right at the edge? Slide that noodle all the way across. And if that noodle doesn't intersect your graph more than one time, then it's a function. It passes the vertical line test. So you think about the noodle test. But the noodle is one of these straight up and down vertical lines just passing across the graph, okay? The domain, remember domain is left to right. Now, let's look at the end. So don't go down and look. The domain is not from here to here. You see where I've got that in blue? That is not correct at all, because it goes further to the left than that, and it goes further to the right than that. So don't make that mistake. How far to the left does it go? Well, check this out. This arrow right here is going this way and this way forever. It's at an angle. This arrow over here is going that way and that way forever. So from left to right, it's actually the whole number line, the whole x-axis. It's going to the left forever and going to the right forever. Because these arrows, that's not going straight up, that's going to the left and up forever. So how do I write that? Well, the domain is from negative infinity to positive infinity. What's up with the parentheses? Infinity. Remember, anytime you write infinity, it's going to have a parenthesis around it, because you never actually get there. What does that really mean? Every number. Every single number on the x-axis has been plugged into this graph to get this line. And this is called a parabola. You'll learn about that in Math 112. Now range is low to high. So I'm going to erase all my domain scribbles in blue. I'm going to make some new scribbles in green to represent range. Okay. Now the lowest value on the graph is very clear. It's right here. How high does it go? Remember, we talked about those arrows at the end. They go up forever. So range might be easier to see. The lowest it is, you see that's -4. How high does it go? Forever, forever, forever. So we're talking about -4. Now that -4 has a bracket because that point's included, all the way to positive infinity, which is on the upside. Okay, and that is your range. Now in red, let's take a look at function values. F of 1. Okay, so x, remember that's an x value. I'm asking you if x is equal to 1, what is y? That's what that question is asking. So when x is equal to 1, here's x is equal to 1, I go meet my graph. There's my point right there. What is that y value right there? Well, if I label that point, that's 1, -3, right? Right there. So the answer is -3. So f of 1, if I write it as 1 question, is equal to -3. Now look at the very bottom question. I almost didn't get it to fit there. But when you look at the bottom question, it says f of x equals 5, find x. So that's asking the opposite when y is equal to 5, what is x? So first of all, I've got to go up to y equals 5. So that's up here, and then I go meet the graph. So I go this way, and it gives me a point there. But look, who said I had to go that way? I could go backwards, and I meet a point there. This has actually got 2 answers. So when y is 5, I've got 2 different points on the graph. Now if I label this point, that's the point 3, 5. And this guy over here happens to be symmetric at -3, 5. So my answers are twofold. I get x equals -3 and x equals +3. And I put a comma between them because that's what you're supposed to do when you have more than one answer. All right, I've got 2 more of these graphs to take a look at, so just hang with me. Just take in as much of this as you can, then you try that homework, it'll really stick, I think. So remember domain. What's important about domain is it's x values and it's always left to right. So first, does this graph represent a function? Does it pass the vertical line test? And notice it does. Okay, it does pass the vertical line test. Look at that vertical line, it only intersects here. If I draw another random vertical line, it only intersects there. There's no way I could draw a vertical line that would cross this more than one time. So this passes the vertical line test. So this is yes. Okay, let me remind you, let's go back and look at one that fails. Look at that guy. Okay, see what I mean? So I draw a vertical line. Right there, it failed. I didn't give you a bunch of them that failed, actually. A circle would fail the vertical line test. A sideways parabola, which I thought I put in these notes, like something that looks like, and I think I drew one for you earlier, this would fail the vertical line test. You see what I mean? But this guy does not fail the vertical line test, therefore it is a function. Now I want to know domain, and people think domain is harder, okay, and so that's why I'm spending more time on domain. Domain we always did in blue, so I'm going to stick with blue. Domain and interval notation. Now, this one's tricky. Notice I did not put these cute little arrows on the end of this, so this literally stops. The graph does not go any further than here or any further than here, okay? Making a big deal about that. So if we wanted the graph to go further, I need to put arrows on the end. But be suspicious if the graph, like if it went all the way up to the edge, that would make me think that it goes on up and off the page. But if it goes there and stops like this one, I mean for this to stop. Okay? Now domain, remember, is how far to the left and how far to the right. Well, this is the farthest to the left it goes. Now I need to kind of back up and do some dashed lines to see where that is. So about there. This guy, I'm going to back up and see, and it looks like about there. So the domain is everything in between here and here. It doesn't go in, there's nothing graphed to the right of that, and there's nothing graphed to the left of that. Now, again, I make a big deal about this. It's not where the graph crosses the x-axis. That's not it at all. It's how far to the left does it go, and then you go back to the axis to see where that is. How far to the right does it go, and you go back to the axis to see where that is. Now, what are those values? So let's look at our scale. Our scale's a little weird, right? 10 is right here at the edge. So that can't be 1, 2, 3, 4, 5. What must it be? Well, that's 2, 4, 6, 8, 10. So this is 4, which means this is 2. So right there in the middle, that's 3. On the other side, this is -2, and this is -4, -6, -8, -10, yes. So this must be -3. So the domain is -3 to +3 with brackets. So you have to be especially careful about your scale, okay? Again, that's not 1, 2, 3, 4, 5. Turns out that's 2, 4, 6, 8, 10. And the y scale happens to be the same thing. So we'll take a look at it now. Now, I'll get rid of my blue, okay? Make a note of that because I'm about to get rid of it. And let's look at green to talk about our range. And range is right here in front of you. Range is y values. You always think about it, it's low to high, and we always write that in interval notation. Notice I put typically, because there is a possibility that it's not all the values between some number and some other number, that it's just points, like our first problems that we did that was just a set of points. And there are other situations where you might just have a list of numbers rather than every number in between. But low to high, let's do that. How low does this graph go? Well, that's the lowest point on the graph. How high does it go? It goes all the way up to here. And notice there's a point for every value in between. Some of them have several x values to represent one particular y value. No way. But anyway, lowest to highest. So lowest. Now, that's a little bit tricky. The negative 20 is here at the bottom of the page, and the positive 20 is at the top of the page. So if this scale is by 2, and I do believe it is, let's check. That's 2, 4, 6, 8. There's 10, okay? And then 12, 14, 16, 18, 20. So this is by 2 as well. So if negative 20 is at the very bottom of the page, what is that just above it where we are? That's negative 18. So we're going from negative 18, and there's something graphed all the way until we get to right here, and then it stops, and that's positive 18. So the range is negative 18 to positive 18, but again with brackets because they are included. Those points are included. All right, here we are, our last example. I know you're sad. Does the graph represent a function? So remember how to do that. Does it pass the vertical line test? What do you think? If you draw any random vertical line on top of this graph, how many times will it intersect? Just once. That's it. Okay, so yes, this is a function. Why? Because it passes the vertical line test. Okay. Next, what is the domain? Remember, domain is left to right. Now, this one's a little tricky. You got to be careful. Notice I had to add those cute little arrows to the graph. So this goes this way forever, and this goes this way forever. What is this way? Well, right here, that's to the right forever and down forever. So it's at an angle. Okay. Up here, that's up forever and also to the left forever. Again, that's at an angle. I know it looks like it's like vertical, like it's going straight up and down. It's not. It's at an angle, and you got to really pay attention to that. Okay, so up and to the left. So the domain turns out, if it's going to the left forever, we've got this whole x-axis completely covered, which means the domain is from negative infinity to positive infinity. Now let's get rid of all the scribbling, and let's try this again and think about range. Now range is a little easier to see on this graph. Now here's where range gets a little tricky, and this is the reason I'm giving you this graph, because I noticed there's a problem in your homework that looks like this. It looks like it goes from here, like the lowest point here, up forever, right? But listen, this arrow is here for a reason. This continues down just like this forever. And they do give one tricky like that in the homework, where the arrow is up higher than the lowest point, but that's not really the lowest point because the arrow implies that goes forever. So in your mind, extend those arrows forever. So the range, how far down does it go? Forever. And there's something graphed all the way. How high does it go? Also forever. So this range is negative infinity to infinity as well. So be real careful with those. So if you have arrows, please notice them and extend them if you need to. I hope this helps you out. Please let me know if you have any questions or you need further explanation. Have a great day.